First of all, let me just welcome you. My name is Victoria Sork. I'm Dean of Life Sciences at UCLA, and on behalf of UCLA, I want to thank you for coming to this event today and welcome you. Before I get started, I just want to say a few words. This event is an annual lecture that's hosted by the Kretz Center for California Conservation Science. You'll probably hear a little more about the Kretz Center, but it's a partnership between UCLA, the National Park Service, the California Department of Parks and Recreation, and Mountain Recreation and Conservation Authority. And the idea is we want to promote conservation in research and conservation in practice. But the person who made this possible is Morton Kretz. He both made the talk today possible, and he also has made the center possible. So I just want to thank Morton for his generosity. It's really rather amazing. Morton has a long list of things that he supported. Obviously, he's been a successful businessman, but he's also been a very, very successful and effective philanthropist. He's donated to UCLA support for the Kretz Hall, which is home of the Institute of the Environment and Sustainability. He supported Kretz Hall at Cal State LA. He's been associated with the Kretz Innovation Campus in downtown Los Angeles. He supported the Path Homeless Housing Complex. I'm not even going to get them all, but I'll say two more that I think are his most recent gifts. Is the Kretz Hall of Hope at the City of Hope, and right now he's involved in supporting the LA River Revitalization Project by supporting a bridge that goes from Griffith Park to Atwater Village, and that would support pedestrians, cyclists, equestrians, increase access. So he's been very, very generous, and he's in particular been generous to help establish what is a very, very innovative partnership. So I just want to ask you to join me in thanking Morton Kretz.
Thank you. I want to thank Dean Sork for being such a wonderful supporter of the Institute of the Environment and Sustainability and the Kretz Center and UCLA. So thank you very much, Victoria. My name is Glenn McDonald. I am the director of the UCLA Institute of the Environment and Sustainability. On behalf of the Institute, I want to welcome you all here today. It is wonderful. This is a wonderful, wonderful event. The UCLA Kretz Center for California Conservation Science we are the home. We host the center. It is one of our 6 research centers at the UCLA Institute of the Environment and Sustainability. And I think I would not be far off the mark if I was to say that it is really one of our flagship centers. And so every day I go to work in our beautiful Kretz Hall, which we thank Morton for, and we have our centers and a group of wonderful, wonderful people, and they all doing excellent work, but I have to say the Kretz Center is really one of our flagships. Now, we're going to have a marine talk, so keeping with the nautical theme, to really have then a flagship, you really have to have an excellent skipper, an excellent captain, and you have to have an excellent chief executive officer. And we in Felicia Federico, who you're going to hear more about, we've had an excellent chief executive officer. But this year, it is a particular delight for me to kind of welcome and pipe on board the new skipper, the new captain of the Kretz Center, and that is Professor Brad Schaefer. Professor Schaefer is a distinguished UC professor, and we poached him from UC Davis, by the way. Okay, so we're persona non grata up there, but anyway. Brad has had an illustrious career as a conservation ecologist, conservation biologist. His specialty are amphibians and reptiles. Amphibians, in a sense, are kind of one of the bellwethers for the health of an ecosystem. In and of themselves, they're interesting, but they tell us so much about our environment and about our environment's health. And in his work, he has worked at a national level, national organizations, state organizations, local organizations, on myriad of conservation issues and conservation biology issues, and really is recognized as one of the international leaders, not just in the study of reptiles and amphibians, but in conservation science writ large. So it was then for us an extreme pleasure to, after an international search, to be able to land, again, back to the marine metaphors, someone as distinguished and as eminent as Brad Schaefer. And so I always want to say this: take the helm, Brad.
Well, gee, thank you, Glenn. There's a whole kind of LA pitch for things that's very, very different than the way we used to do it up at Davis. And Glenn, if he has nothing else, has that pitch down to a true art. And I thank you very, very much. That was an absolutely lovely introduction. I want to try to be brief because I want to save as much time as we can and we need for our incredible guest today, Sylvia Earle, but I do want to say a few things. First of all, as Glenn said, I moved down here from UC Davis after almost 24 years up at Davis, and I moved a few months ago to take over the faculty leadership of the Kretz Center for California Conservation Science. And just briefly, so what is the Kretz Center all about? It exists because of the incredible donation and support that Morton Kretz has provided to our unit. And we really have kind of three motivations, and they are science, education, and outreach. We are the Kretz Center for California Conservation Science. And so the science is the biggest, in my opinion, sort of the biggest single element of our entire operation. But it's science, not just for science's sake, but we hope science to make a difference. It's science that will make a difference in terms of concrete management and policy in the marine realm, in the terrestrial realm. My own specialty happens to be conservation biology of endangered species. And I want to really motivate the Kretz Center, the community at UCLA, and the community in Southern California to do as much as we possibly can to bring the strongest possible science to the table in order to accomplish real things of real value to the conservation of our local flora, fauna, environment, air, and land. That's a big order, but science has a lot to contribute to it, and we want to make sure we can do that. Education is incredibly important, and education, it's what we all do at UCLA, right? We're educators. We teach people. We teach the best and the brightest, I believe, undergraduates in the nation how to become leaders of the next generation. We teach ourselves. We try to have outreach to K through 12 programs as well, and that's a critical part of conservation work, is making sure people are educated. And the third part is outreach. And in many ways, I'm not sure if today really counts as education or really counts as outreach, but outreach is taking our message, taking the message of absolutely the best and brightest professionals in the world and bringing their message to us and to our larger community to promote conservation in California. And today's event and the Kretz annual lecture, which this is the third of our annual lectures, is just that. It's an outreach and educational opportunity for you to interact with and hear from an absolute world leader in conservation, and hear what she has to say and how her leadership and guidance has helped form conservation policy around the world. So that's our mission. We accomplish these things in a few ways. We accomplish them by having what we hope is a very strong and developing and growing partnership with our partner agencies here in Southern California, and Victoria also already mentioned that. Primarily right now, that's the National Park Service, California State Parks, and the MRCA, the Mountains Conservancy. And those partnerships are unbelievably important. We have several folks here in the audience today who are from those agencies. Some of you I know, some of you I don't know, but I hope to get to know. But that partnership is absolutely core to our mission and to being able to accomplish real things. Before I get on to our speaker, there's two other people I would really like to highlight and mention. And the first is the executive director of the Kretz Center for California Conservation Science. That's Felicia Frederico. She's been organizing and motivating a lot of activities in the center for the last year and a half. Until I got here, we formed a very strong partnership in doing Kretz work. The other is Mark Gold, who's just moved to UCLA from his NGO, Heal the Bay. Mark is an associate director of the IOES, the institute that Glenn runs, and is an incredibly important partner with the IOES and with the Kretz Center. These are two individuals who are absolutely central, at least to my work and my mission in the Kretz Center. And I thank you both very, very much for your work. Okay, with that, let's think a little bit about Sylvia Earle. For those of you who like rock and roll, as I happen to, one of my heroes in rock and roll is a guy named Lou Reed. And Lou has a song from maybe 20 years ago called What Becomes a Legend Most. And I think in the world of conservation biology, the world of oceanography, the world of protecting the oceans, the legend is Sylvia Earle. She is, at this point in time, without a doubt, the most important, the most sort of meaningful, and the most effective conservationist for the world's oceans and the marine life within those oceans of any person on the planet. And we are incredibly proud and incredibly happy to have Sylvia here as our guest today and our speaker. She's been referred to as her deepness, which I think is just wonderful by the New Yorker. There's all kinds of wonderful stuff. Dial her up on Google and you can see the various nicknames that she has, many of which are absolutely fabulous. Dr. Earle has a long history as an academic scientist. She received her bachelor's degree from Florida State, her master's and PhD from Duke University. And it turns out today, I didn't realize this, I was chatting with her for a few minutes a little while ago, and it turns out during those early formative years of her life, what did she study? She studied salamanders and turtles, okay? Now, personally, this means to me that she is part of the elite brotherhood of which I am a member. It also so happens she also seems to like oceans and oceanography quite a bit. So, so in that sense, perhaps she's a little bit broader than I am. Since receiving those degrees, Dr. Earle she had for a long time, was a curator at the California Academy of Sciences up in San Francisco. She's had appointments at UC Berkeley, at Harvard, at a variety of the world's best universities in the world. And that certainly is the sort of academic part of her life and of her achievements. More recently, now 20 years ago, she was chief scientist for NOAA, the National Oceanic and Atmospheric Administration, very, very important position in Washington, setting policy in that position. And she has been, for some time, had this unique and I think absolutely wonderful position, which is an explorer in residence for the National Geographic Society. And again, if you dial in a little bit and you ask what makes someone have that unique position of being an explorer in residence, it's that she's spent thousands of hours underwater studying the world's marine ecosystems. She has had records for the deepest dive of any person on Earth, the longest time underwater, all kinds of amazing accomplishments, amazing missions, amazing explorations that units like, or operations like the National Geographic Society recognize. She is, without a doubt, an absolutely astonishing human being, an absolutely astonishing conservation scientist and conservation biologist, an absolutely astonishing spokesperson for the world's oceans and their conservation. There's no one else like her on the planet, and I'd like to have you join me in welcoming Dr. Earle.
It is a privilege to be here in sunny Southern California, where I actually resided for about 5 years. I moved here from Massachusetts in 1970 and then slipped up the coast in about 5 years later, 76, and I've been in the Oakland, California part of the world ever since. But it started in New Jersey. I'm a Jersey girl, what can I say? My parents moved to Florida when I was 12, and my backyard became the Gulf of Mexico. And yes, I'm a critter person. People ask me, how did you get to be a scientist? How did you get to be explorer in residence at the National Geographic? And I say that it's really pretty simple. And that is, it's true, now there are about a dozen explorers in residence at the National Geographic. And every one of them has this in common. They are little kids who never quite grew up. They do what kids do. You start out as a kid, but then you don't quite make it into that other hallowed area that they call adulthood. They do what kids do. They ask questions. It's who, what, why, where, when, how, and they never stop. The thing is, that kid is in everybody. It really is. It gets buried sometimes under the avalanche of what it takes to live in the 20th and the 21st centuries, and I guess it's going to get more and more complicated as time goes on. When I arrived, there were only, I say, 2 billion people. It took until 1800 for there to be 1 billion, and as you know, probably at this point, we now have more than 3 times the number of people on the planet as when I arrived, and yet the planet stays about the same size. I mean, it's... And our success, our prosperity, has come at a cost that we don't always take into account. We don't really account for nature. It's just the way of our species. Over the years, we do what every living creature does. You just use the space around you to prosper and survive. Until about 10,000 years ago, our numbers were really quite small on this little blue speck in the universe. But we actually entered a geological quiet time, sort of a stable period that enabled humankind to prosper. And in my images that I'll show in a moment, I will get into that a little bit. But as our numbers began to prosper and grow, the world around us, the natural world, paid the cost. You know? We cut the trees, we turned rivers into engines for energy. We consumed the wildlife around us. Even as early as the beginning of the 20th century, birds were consumed commercially by the truckload. One of my uncles, in fact, was a market hunter in New Jersey for ducks and geese and little furry things in the marshes. We've pretty much given up, by and large, the commercial exploitation of birds. We've done a real number on the habitat, but killing birds to put in the markets for groceries, that's kind of phased out as we realize that there are limits to what we can take if we still want to have birds. We haven't learned that yet with the ocean and fish. We still take wild fish, bushmeat, if you will, by the ton out of the ocean. We don't even know the names of some of the things that appear on our plates. We still have this Neanderthal attitude about the ocean. It's still, in the minds of many, so vast, so resilient. It doesn't matter how many fish we take. It doesn't matter what we put into the ocean, because it's so big, it's so resilient. What can we puny human beings possibly do to change the nature of the ocean, the nature of nature? Well, here's the thing. Kids who, not just the kids, people today, I'm one of them, that it's easy to get depressed thinking about the state of the world and what we're doing to it, what we're doing to one another. There's this lofty goal of trying to find peace on Earth for human beings. And with luck, we'll make it someday. But it requires that we make peace with the natural world. It's our only hope. We must consider the trees, the salamanders, the fish, the whales, the water, the sky, all of the things that make this planet, not as an option, not as a luxury. It's our life support system. And we've been treating it like an endless bank account. I gave a talk at the World Bank a couple of years ago, and I put that beautiful image of Earth from space that didn't exist when I was a kid. And now kids grow up at least having that in their heads from the early times that, oh, that's what the world looks like. So I put this image up on the screen and I said, there it is, the World Bank. That's it. We've been drawing down the assets through the history of our species. It's only now, only at this magical time that we all share, best time ever to be alive, as far as I'm concerned. Now that we know that there are limits to what we can do to our life support system. You think about it. We did some terrible things going back through history. We, according to one of my great heroes, Ed Wilson, a Harvard biologist, said human beings, in the course of our history, have eliminated many of the large, the slow, and the tasty creatures that share the planet with us. Well, we're doing the same thing to life in the sea. And in a way you can kind of excuse it. I can think, now we know, but if you didn't know, I mean, it's hard to blame people if they do things in ignorance. Well, we've been not entirely ignorant, because even 100 years ago, people could see that when our numbers were less than 2 billion, our capacity to just transform the nature of the world, eliminate most of the big forests in Europe, change the course of rivers, eliminate individual and entire species and entire systems from the planet. And you knew it was happening, but you still did it, because generally speaking, people think it didn't thought, and maybe some still do, and it doesn't matter. What difference does it make if we lose turtles, some say? What difference does it make if we lose birds, some say? Well, there are fortunately many more who do get it and understand that even if it's just for ethical reasons, even if it's just for aesthetic reasons, there's a good case to be made for protecting the natural systems. But if you layer onto that very selfishly, oh, by the way, they keep us alive, that oxygen gets generated every day and refreshed and replenished. We draw it down, and all the other creatures, the whole natural world, has an impact on the world around us, them. It's the way the world works. But we have a magnified impact on the way the world works. We didn't know that when I was a kid. Didn't know that we could change climate, weather, the chemistry of the planet, chemistry of the ocean. Didn't know we had the power to eliminate 90% of the sharks, swordfish, tunas, on down this long list of creatures in the sea that have really been greatly diminished on my watch since I was a child. Now we know, and I think that's the great news. And this institution, UCLA, the Park Service, all of you who are here with affiliations, ties with many of the right institutions, some of them right here. This is exactly what we need to be doing, to understand the world we live in, and then to be a voice for that world, to be ambassadors, if you will, to our species, those who don't know what you know. There isn't anything more important than this at this point in history. We had a little more leeway going back 50 years, 100 years, 1,000 years than we do now. But we are at tipping points everywhere you look, so that knowledge-based, science-based conservation, policy, whatever it is, should be on the balance sheet of everybody's life, whatever you do, whatever your specialty, whatever your talents, use them. Try to take care of the natural systems that keep us alive. Everything else follows from that, even peace. People who are hungry, who don't have a good water supply, who are crowded into small areas and the whole world around them is diminished. That's when poverty strikes and wars and conflicts of various things start and continue. It's part of what's now driving the conflict that we see in the world today. A reduction of the natural systems that lead to prosperity if they're maintained and cared for. So I'm going to focus now mostly on the blue part of the planet, but everything ties together, and everybody is tied to everything. One of my professors at Duke University years ago was Dwight Billings, and he entertained his students, I was one of them, in this big circle, and it was just crisscrossed like this with lines. It was just nothing but lines connecting all around. And he said that's the way the world works. Everything connects to everything else. It's the biosphere. I think that was the kind of the birth of that concept, that term in the 1950s. It's taken us a while to get here, but now we're here. We do understand that we have the power to change the nature of nature. We're doing it. Let me see if I can get my clicker. Yes. See if this works. It does. Huh. Well, this is the view that many people have of the ocean. A lot of people never get to see the ocean at all. A lot of people, I've met some of them, say that why should I care about the ocean? Because people don't drink salt water. I had a reporter in Australia just put the question to me. She said, I don't swim. I don't go out in a boat because I get seasick. If the ocean dried up tomorrow, what difference would it make to me? And I've given it some thought, about a millisecond. And I said, right, get rid of the ocean, and what have you got? You've got a planet a lot like our sister planet, Mars. A planet that's beautiful to look at, but not a great place to live. Because it lacks the thing that we have here. We have an ocean, water. Water's the key. 97% of the water is in the ocean. It gives into the atmosphere the fresh water that, of course, falls back on the land, and sea drives the water cycle. It's home for most of life on Earth, the ocean, because that's where the water is. It's where the greatest diversity of life is, in the sea. When you dive into the ocean, and I love diving into the ocean, it's like diving into the history of life on Earth, because the basic categories of life that were there early on, 1 billion years ago, 500 million years ago, 200 million years ago, 100 million years ago, 50 million years ago, 10 million years ago, whatever. They're basically the big, broad wedges of life are still there. Only about half of the phyla of animals on the planet occur on land, but essentially all of them have at least some representation in the sea. And I love talking with Ed Wilson about this business of diversity because he thinks insects really rock. And they do, they really do. Beetles, of course, ants. And if you think in terms of a category of life, that dominates in terms of what we call species, putting aside the microbes in a category all by themselves in terms of diversity. But, 500,000 species, just insects, and that's a great understatement. There are a lot of them that we don't know about yet, even in our own backyard. But a lot of places that we haven't even looked. And the Census of Marine Life that recently scoured the oceans of the world over a 10-year period to try to figure out how many of what kinds of creatures, how many species at least, have lived in the ocean, do live in the ocean, and will in the future live in the ocean. It was a magnificent enterprise that took, a decade. Thousands of scientists from all over the world pitched in. The effort was funded by a number of individuals and institutions who bought into the concept that we ought to at least know who lives in the ocean, who lives on this planet, who shares space with us. Who are they? What do they do? What they found, anyway, in the end, was a catalog, provided names and museums, that, searched all the records, conducted expeditions, came up with about 250,000 variations on the theme of species. But the estimate is there may be minimum 4 times that number, and some say even that is a very low figure. You think of what we now know about how to consider what a species is, that we didn't have the techniques to determine the many variations on the theme of life, and the distinctiveness that set one kind of creature apart from another. Many that look the same, that turn out to be very different. And certainly on the microbial level, from where we stand, big creatures that we are, microbes kind of all look alike. They're tiny little specks. But now that we have the capacity to look at the DNA, we know that the variations are enormous. We haven't even begun to get our minds around just how enormous. But we're starting to realize that there may be, even in a more traditional way of defining species, on the order of 50 million species of critters in the sea. And if you add the microbes to that, we're talking hundreds of millions, maybe, who knows, big B billions, depending on how far you want to stretch this DNA business. So, to explore the ocean, we're just getting started. Only about 5% has been seen, let alone really explored. Only about 5% has been mapped with the same degree of accuracy that we have for the moon, or Mars, or Jupiter. What are we thinking? We need to get down there, under the sea, and we are so lucky. Again, one of the great reasons for being alive. And then some of you, I met some of you just before this talk, who are getting certified. Yahoo! Go for it. My mother waited until she was 81. Don't wait until you're 81. She will tell you that. And she would say, if you are 81, there's still time because you're still breathing. If you breathe, basically, you can die. I mean, what's the big deal? You drive a car? Well, some people don't like to drive cars. That's okay. Take a bus or a taxi. And in the ocean, there are other ways to get around. Well, actually, I love living underwater, staying underwater, breathing the air, or compressed air in this case, that is at the same atmosphere as what is the depth that you're at. In this case, it's the Aquarius underwater laboratory in the Florida Keys. It still takes scientists and NASA astronauts and others who live underwater. You don't stay in there any more than you have to. You sleep, you eat, you write in your notebooks, you look through microscopes, you take a shower, but you use the ocean as a laboratory. What a concept. Southern California came perilously close to getting this underwater laboratory, going back a few decades. But politics intervened, and it wound up in first the Virgin Islands and then where it presently sits in the Florida Keys. I had a first chance to live in an underwater laboratory 42 years ago, 1970. I had just moved to Los Angeles, and I had been at Harvard, I did one of those numbers that graduate students sometimes do. You see the bulletin board with all these flyers. One of them said, "How would you like to live underwater?" And as somebody who had been splashing around in various oceans already at that point, it seemed like a good idea to me. And so I took down the information and submitted a project along with scientists, mostly from the United States, but from all over the world, about what I would like to do if I had a chance to spend 2 weeks living underwater, sleeping with the fishes. Day and night, you could actually be in a place 50 feet underwater in the U.S. Virgin Islands. So I was one of those who got selected, but it was just one of those tricky things. Those of you who weren't around in 1970, and there are some in this room, probably just can't imagine the idea that women weren't even expected to apply to this project. I mean, they didn't even bother to say no women. Astronauts did not include women in 1970. It was a number of years after that that they began to accept a few women to be astronauts. And nobody thought that anybody would want to be an aquanaut either, but some of us did. In fact, there were 2 from Scripps Institution of Oceanography who applied. They got accepted, I got accepted. But it was only after some deliberation on the part of the powers that be, including the head of the program, Jim Miller, who I think had a really good marriage, and I think he really had a good mom, because he was asked by some of the crusty Navy guys who really objected to the thought of having women as a part of this program. He said, in response, "Shall there or shall there not be women?" He said, "Well, half the fish are female. I guess we could put up with a few women." And he stared them down, and so some of us got a chance, but they wouldn't let men and women live together. Now that's another big concept. Women go up in spacecraft, they ride buses together. I got on an airplane with men to come here today. But back in 1970, it was considered a little too, you didn't know what that would lead to. Hanky-panky on the reef is what they said at the time. They didn't want to have that. Wrong headline. So anyway, there was a women's team. I got to be the head of the women's team. And there's another thing. They didn't want to call us aquanauts. Or maybe they did, but somehow the press got a hold of it. We were the aqua babes. We were the aqua chicks. We were the one I liked the most. Or maybe I liked it or didn't. They were the aquanauties. And I thought at the time, what if they asked started calling the astronauts the astro hunks? Or, they didn't. They called them astronauts, and it was a respectable thing to be. As it turned out, we didn't care what they called us as long as they let us go. And we did go. We had a wonderful time as scientists, 1 engineer and 4 scientists. And to me, it changed my perspective on things forever. I got to know individual fish, not just species, but individuals within a species. I recognized faces. It was a transformative experience to be in the fish's neighborhood, as Fred Rogers later called it. And you get to know your neighbors, and that's how it was. But it's still limited. Breathing compressed air or even exotic mixes of gases, our physiology makes it possible for us to go under special circumstances. Not everybody can do, almost anybody can dive 50 feet, 100, even 150 feet, 50 meters. But to go deeper, the ocean average depth is 2.5 miles. It's 4 kilometers maximum, where James Cameron just went a couple of weeks ago, 7 miles down, 11 kilometers. That's most of the world. It's most of the ocean. It's where most of life on Earth is. It's below where divers go. It's mostly dark. It's cold throughout much of the range. Cold for us anyway, but just right for the creatures that live there. Think of it. And you get about it depends on where you are. In the open ocean, clear, open, blue water, at about 100 feet, it starts to get bluer and bluer and bluer. And when you get to 500 feet, it's really like a deep twilight. This is the twilight zone. where it's lighter up and it's really dark going down. At 1,000 feet, I've been at 1,000 feet in clear ocean water. You can still see the faint glow of light up there, and it's really dark everywhere down. Below 1,000 feet, it's dark all the time, not just the day-night cycle, but dark. Most of life on Earth lives in the dark, not just in Washington, D.C. It's true. And not just Washington, D.C. either. This was at 1,250 feet in Hawaii, and I could see the faint glow of light above, and all around the flash, sparkling glow of bioluminescent creatures, that firefly kind of light. It really is part of what sort of nudged me out of academia, nudged me out of my ivory tower, if you will, living underwater, getting to do some really interesting things, and actually doing something that any sensible scientist probably would really hesitate to do. I started a company, not knowing anything about law, not knowing anything about accounting, not knowing anything about anything with running a business, but what I did want to do is solve the problems of going into the ocean. So in 1980, I actually started deep ocean engineering. I'm not an engineer, but I began collaborating with engineers who knew how to design and build little submarines and other technologies for access to the sea. Now, never for an instant stopped being a scientist. I mean, you can't. Once a scientist, you're stuck. It's there. It's with you forever. It's who and what you are. But to develop tools, I mean, I felt in a way like it's the microscope for the sea. It's the macroscope. It's a way to actually see things you otherwise couldn't see, like telescopes. You can't see the stars until you get a magnifier. Having submersibles, having underwater robots that can at least vicariously, if not actually, take you down so you can see and understand where most of life on Earth actually lives. And do something about it, because the world, we also know, is changing. And it's not limited to what we can see on the surface. The ocean is seriously changing. So this is a descendant of a little submarine called Deep Rover that the company that I started actually designed and built. It's a little bit like Jim Cameron. No astronauts, somebody else gives you the spacecraft to fly. They even give you a salary, they pay you. Nobody paid Jim Cameron, nobody paid those of us that were involved with deep ocean engineering to be whatever it is, submarine pilots and so on. You had to first start the company, design the sub, raise the money to build the sub, figure out how to operate the sub, then get money to have an expedition so you could use the sub. And all those things we kind of did. Certainly Jim Cameron did that and has made a huge difference in the way we see the way the world works. And I hope, well, inspires others to not say, I can't get to the bottom of the ocean because there's no submarine out there. Well, go design one, build one, and go fly one. I mean, these are possible things that anybody can do if you make that a priority. And for me, it was a priority. So I took a chunk of my life, 10 years, and devoted it to trying to figure out, by having first one and then a second and a third company, to try to solve some of these problems. It's not like a Google, it's not an IBM, it's just a little tiny company, but it's solving problems to do things in the ocean. The most recent iteration of this, I started in 1992, after I left sitting in Washington for a while as the chief scientist at NOAA. Deep Ocean Exploration and Research. The other two are basically gone, but DOER Marine, I struggled with that for a while, and then I foisted it off on my daughter and my son-in-law. And so they own it, operate it, and they're doing great. They really are running a company. They really are designing and developing equipment for ocean access. And Scripps now has a 2,000-meter remotely operated system that they built. The one thing I can say is, hey, I started the company. I don't do anything now, but sit back and watch it prosper. And things that you can do with your life, because we live in a free country. where choices are available. It's one of the best things we have going for us. You can do things with that gift that you have of life. Whatever makes your heart beat fast. And so this descendant of the Deep Rover was built in Canada. There are about 20 of these little one-person subs that are so simple to drive, even a scientist can do it. And I'm living proof. Actually, about 100 scientists have tried and succeeded in driving this little Deep Worker sub. And for 5 years, during the National Geographic Sustainable Seas expeditions exploring the coastline of the United States, we had these little subs available. And we're using them to dive right off the California coast, off Hawaii. We went into the Gulf of Mexico, up along the coast of the eastern seaboard, and were able to explore down to as much as 2,000 feet. Still the skin of the ocean, still not getting into the real heart of the ocean, but a great beginning. Just a year ago, I used a two-person version of this Deep Worker in the Gulf of Mexico with a project to go try to find out what happened to all that oil. Anyway, Alvin was there a little more than a year ago before they broke it down into little bits and are trying to reconfigure it so it'll be a 6,000 meter sub in due course. Well, that's about, half the ocean's depth. That's a good start, but why are we still, up here when we really need to have the tools to explore to full ocean depth? And thanks to Jim Cameron and some other bright sparks around the world, maybe in the next 10 years we will have better access. I mean, Russia has 3 6,000 meter subs. India is building a 6,000 meter sub. China is this summer going to test their 7,000 meter sub. France has one. What are we thinking that this country doesn't have the submarine that can go that deep? We have 2 submarines out in Hawaii, the 2 Pisces subs. They can go to 2,000 meters, a little more than a mile. But NOAA, in all their wisdom, they're about to zero out the budget for those little submarines starting in September. So we're kind of stepping back from exploring the ocean with the technologies that will enable us to do that. We're putting zero funding on the Aquarius underwater laboratory. Go figure. There's the Mir sub, one of the 3 Mir subs in Russia. And this is a little private enterprise that I also love. I mean, anybody here, if you had an invitation to hop in a little clear bubble like this, would you say no? Or would you say, let me at it? Well, all you have to do is go to Cocos Island off the coast of Costa Rica and sign on to the Undersea Hunter. And yes, you have to pay for it, like getting an airplane ticket. But you can go down to 500 meters. You can get down to that twilight zone. And little kids can do it. Anybody can do it. All you have to do is be able to breathe. And you can sit there and go lofted into the depths. Warm and dry, you can watch the fish swim by right outside your clear sphere. And there's a manipulator arm. Actually, the company that my daughter and son-in-law have, DOER Marine, built the manipulator arm that went down with Jim Cameron to the deepest part of the ocean. So a little bit of California made that historic descent a couple of weeks ago. In Italy, they're building some submarines that have diver lockout capacity that swim out the back side of this, where there's a dry place up front, like the Johnson Sea Link submersibles that operated in this country for more than 20 years, since 1970, but they were sold off just last year to Brazil. So we're losing the capacity, but we don't have to be content with that. This is a clear sphere of vision that I hope will soon be the basis for a new generation of personal submersibles to take 2 or 3 or 1, whatever you want, individuals. If you go to Hawaii, you can get on a passenger submarine and glide down, buy your ticket, get on the underwater bus. So it's happening. It's like the early days of aviation. We're just beginning to explore and figure out and understand that, yes, we can have access to the oceans below. It was so improbable to my parents when they were kids that anybody could fly across the country. that we would go to the moon was just an impossible vision. And here we are in the early part of the 21st century, and there's still a lot of people who think it's, why go into the ocean? Why explore? Why do these things? And why not? Why not get out there and see what life is like in the deep sea, where hydrothermal vents have given rise to kingdoms of life that we didn't know existed when I was a kid. Get down even a mile where sperm whales dive. Those are goals within our grasp if we choose to go for it. Well, I hope on our watch, in our time, we will come to respect the many variations on the theme of life in the sea, the way, at least to some degree, we've begun to respect the many variations on the theme of life on the land. At least to think of fish like birds, and to realize that everyone is individual, that there are no two parrotfish of this species with freckles on their noses. I guess they have noses. Exactly the same. They're all different. If you look at a big herd of zebras, or if you line up 100 frogs of one species, you'll see that they're all different. Their patterns are different. No two little fish of this sort with spots on their nose, snout, or you can't see this very well. It's a big moray eel. No two alike. No two big turtles exactly alike. Now here's the thing. These creatures, some of them, are just regarded as commodities. They're taken the way we, as casually as we eat Kentucky Fried Chicken, you eat the wildlife that comes into the markets. We don't have Kentucky Fried Bird. We have chicken. You don't have, but you do have catch of the day. You do have fish and chips. What kind of fish? You have no idea what kind of fish is appearing on your plate. Even if they do give it a name, it could be any of 20 or 30 different variations on the theme. We now have the power of knowing and of appreciating why these little guys matter. The octopuses have been around for 300 million years, and on our watch, we're losing cephalopods, squids, and octopuses. Birds were beginning to get it. We get it with cats and dogs and horses and kids. They're all different. We recognize personalities. It's not just about the DNA. I got to meet this bird early this year, January. I went out to Midway Island. This is the bird known as Wisdom. She's 61 years old. She was tagged back in the 50s. They know that she's at least 61. And this is her egg of this year. And it hatched, I later discovered. Here's the thing. What has happened in her lifetime? 61 years. The world has changed. Now we know that in this time, squids, among other things, but the tunas, the swordfish, the whales. Whales had already been greatly depleted. Some of the whales are starting to come back in terms of their numbers. But the atmosphere has changed. The temperature has changed. There are plastics in the sea that didn't exist when she hatched, didn't exist when I hatched. The world is, in a few decades, experiencing change of geologic magnitude. It's a fact. And here we are, watching this swift change slide by on our watch. I saw a few monk seals, these rotund, wonderful creatures out in Hawaii, share space with albatrosses. But in the Gulf of Mexico, in the Caribbean Sea, there was a species of monk seal until 1952. I was a kid. There were seals in my backyard, and I didn't know it. They're gone now. There's still a few in the Mediterranean. This is just one example of thousands we could point to. It was there on our watch, and it's gone. Irretrievably gone. Never again will there be a creature like this. Unique DNA, unique personalities, every one different. Everyone had whiskers that were a little different from every other face of a monk seal. So also earlier this year, I went to Antarctica. I met some other albatrosses there and saw up close and personal what's happening to that polar sea. I'm sure that some of you in this room have been to the far north, to the far south, and have been as moved as I have been to see that amazing part of the world that governs much of how the world functions. People, we now know, most people have the capacity to know, that the world is changing. Just as wisdom may know that the world is changing. Or that loggerhead turtle that I saw 70 feet down in the Gulf of Mexico with that up-close and personal face that was on the screen. But they don't know why the changes are taking place, and they don't know what to do about it. Even if they did know, they wouldn't know how to cope. We're the only ones. We do know why. And we do know what to do about it. We have the power. And it's only now, which is why, back to the beginning of my remarks, this is the best time to be alive, if you could choose, in all of history, going way back into the beginning of humankind. We didn't know what we now know. Go forward another 50 years, or 100, or 1,000. Choices that we now have will be gone. Half the coral reefs are already gone, or are in a state of great decline. We've seen this fabric of life. We've seen the ice change in the Arctic, in the Antarctic. We've seen a decline on our watch of populations of creatures that were around long before there were humans. Why? I don't have any idea of why. I mean, I try to imagine why would we go all the way to Antarctic waters to gather the cornerstone of Antarctic ecosystems, krill, that we don't even eat. They're just commodities, taking thousands of tons of these creatures out of the system to market all over the world. They're just looked at as pieces of meat, little tiny pieces of meat to be sure, but there are a lot of them. And we think it's okay. Except now we know this isn't okay. We have the power to undermine the systems that are at the cornerstone of not just penguins, of whales. Of course, it matters to us too. And our new ability to go out doing things that none of our predecessors could do, because we didn't have the capacity to get 2,000 feet down using materials that didn't exist when I was a child. These nets that would capture whole populations of creatures such as orange roughy. If I'm racing ahead here. Very few people have actually seen one of these fish except on a plate. Orange roughy. Turns out it takes 30 years for them to mature. They may be 100 years old by the time they come to a supermarket near you. They come to supermarkets near me in Oakland, California, and sell, according to my last count, $8.95 a pound. But what does it take to make a 100-year-old fish or a 1,000-year-old tree? We haven't really been accounting for what we take from nature. And it's catching up with us. Now we know. Our ability to extract tuna from the sea is eliminating tuna from the sea. Our taste, our newfound taste, our love of sushi and sashimi and tuna, rare, tuna this way, tuna that way, in a can, out of a can, whatever it is. And it's not just bluefins. All the tunas are vulnerable to our bottomless appetite for ocean wildlife. And it's happening on our watch. It certainly has happened to sharks. When I started diving in 1952, I was told to be careful. There are man-eaters out there. And then I stopped worrying when I realized I don't have to worry about man-eaters. I don't qualify. But they have to worry about us, man-eating sharks, women too. Only about 10%, in some cases 1 or 2% of some kinds of sharks remain from when I was a child. We have that kind of power to just draw down the assets. With whales, we stopped killing them by and large. 3 nations still kill whales for food: Iceland, Japan, and Norway. None of those nations are exactly starving nations, but they do still kill 60, 70, 80-year-old animals for sale. And part of it is for food, sometimes for oil, but whatever. They're used as commodities. But by and large, people have begun to see whales with new values. Even economically, a whale alive gives us back a whole lot more than a one-time sale of the creature. We had a wake-up call about costs a couple of years ago, but it still hasn't quite sunk into our beautiful minds about the real cost of cheap oil, cheap energy, that have driven us to the point of where we are. We have satellites, we have astronauts, we have airplanes that fly, we have the internet, we have a world that works in our favor, given our drawdown of fossil fuels, coal, oil, gas. It's served us well. And maybe the most important benefit that we've derived from the burning of fossil fuels is the knowledge that we have to shift gears, that it's not going to serve us going forward. It will serve us in a negative way. It's helped us positively to get where we are. But now we know, and we just must shift away, just as we shifted away from whale oil when the whales were disappearing, but now for other reasons. The burning of fossil fuels, we now know, is altering the nature of the planet, not in our favor. This is a familiar graph to some of you, just showing the loss of summer ice in the Arctic. It's a graph that should be familiar to everyone, and it shouldn't stop in 2007. Now it's 2012, and it goes further off the edge of this graph. The summer ice is diminishing, by nearly half since 1980. This is geologic change while we're watching it. What about this don't we understand? Polar bears, we know, are in trouble, but it's not just polar bears. It's life on Earth is looking at unprecedented change with unprecedented speed. Well, maybe there was great speed when comets struck the Earth years ago. That was pretty fast changing of gears, but some regard us as that comet that is striking Earth, initiating changes that are not in our favor. It doesn't turn out to be in the favor of the many creatures that are affected globally, other than humans either. The good news is 10% of the sharks are still out there swimming around. We still have 2 of the 3 species of monk seals swimming in the ocean. We still have half the coral reefs. There's still some tuna fish. There are a few oysters in Chesapeake Bay. We have a chance. We have to use that thing that we have that is truly special, and that's our mighty brains, our ability to look back in time, to look ahead in the future, to figure out a path that is enduring for us, and to realize it isn't just about us now, that everything that we have, that we value, we have because we have a history that precedes us by thousands of years. So that I can stand here, I could get here in a plane that I didn't design, didn't build. Somebody else, some other members of my species invested in that. Every one of us is wearing something that we didn't make. I mean, we all benefit. Going forward, we are going to be part of that process to make the future possible for those who follow us, just as we are possible enjoying what we have owing to those who preceded us. One of the things that has made my life a lot easier is the invention of plastics. I love plastics. I think I have plastic on my shoes. I probably have a plastic zipper. Plastic here, this is plastic. It isn't plastic that's the problem. But we do have a problem with plastic, what we do with it. The single-time use plastic that gets thrown away after using a thing once, straws or bottles, whatever it is. And it's really evident now in the ocean. 50 years ago, 20 years ago, we didn't know. But now we know. We're armed with knowledge. Unfortunately, that albatross doesn't know. She's sitting on a nest of fishing line plastic fishing line. It was just, fortuitous from her material that was handy, and she made a nest of it. But when the albatrosses and other seabirds fly out into the ocean picking up what they think is something yummy to bring back to their chicks, it's often plastic. And many chicks never get to fly because their goozles have been stuffed with these materials that are certainly not nutritious. They just clog them. A whale came ashore several years ago here in California, a sperm whale. It had more than 400 pounds of plastic in its stomach. So what are we thinking? Changing the world in this way. The derelict fishing nets that now are strung around the ocean, thousands of miles of long lines, nets that keep on killing once they've been discarded in the sea. We have entered what some are calling the Anthropocene. Here we are. I come from the pre-Plasticozoic, I tell people, but so I know we can get along without it, but I love having it. I just wish we would treat it with more respect, treat the planet with more respect. Another piece of good news, the economists are getting into the act when it comes to the environment. So, The Economist, this lofty magazine published in the UK, circulated around the world, has several times focused on this issue of how the world is changing and how it affects the economy. Looking at the natural world as assets, looking at assets that we're drawing down, and thinking about what we can do now that we know. The World Economic Forum in Davos in the last several years has been including increasingly a little bit more every year. This year, I was there for the first time, and I had a chance to sound off about the ocean. But I did more listening than I did talking. And one of those I listened to was Johan Rockström, who's a Swedish scientist who, along with others, including Jim Hansen, has considered what's happening in terms of what we're doing to push the planetary boundaries. Things that, if we exceed those boundaries, we're in real trouble. They may be irreversible, but they will be beyond a certain point, tipping points, if you will. Carbon dioxide in the atmosphere, acidification of the ocean, the changing chemistry that may alter the phytoplankton that does the heavy lifting when it comes to generating oxygen and grabbing carbon. Where are the points in how we use the planet's resources that we use them to the point where they cascade out of control? So, mathematicians, economists, scientists, of course, are teaming up to look at the world with new eyes. Sorry, this is not very clear, but it just is an indication of the new view of the world. We now light the world up with our use of energy, and we need to light it up with our intelligence as well. Thinking about our pressures, thinking about certainly climate. It should be front and center for everyone. The loss of the natural systems that keep us alive. And there's always that wonderful element of surprise. Earthquakes that come along unexpectedly and change everything, as an earthquake just did in Japan. But more than that, suppose the microbes decide to make a quantum shift in some fashion. Our lives are dependent on maintaining microbes around the world, in our bodies, in the ocean, in the water, on the land, in the soil, more or less the way they are now. They're kind of, it's taken all this preceding history, hundreds of millions of years of fine-tuning to get a world that works, and the microbes rule, bacteria, and the other small things. This is a graph that Johan Rockström gave me to use, just looking at 100,000 years, the skin of history, even as humans define history. Because our roots go back to at least 100,000 years. Maybe if you think about where do we come from, who are we, where are we going, maybe several million years. Depends on how far back you want to count for what is human, after all. But just in this 100,000-year piece of history, the skin of all of Earth history, ice ages have come, ice ages have gone, climate has been up, temperature's been down. Here we are, the last 10,000 years, have, as they say, been a period of grace that have enabled our species to survive. And we have a planet that works. Isn't it perverse that it would seem that we're doing everything in our power to shake things up, to get back to this, instead of how can we hold the planet steady? What can we do consciously to maintain a steady course? Protect nature. Do what the national park system is doing, doing what this center is doing what you are doing. Let's understand the way the world works, and then let's do what we can, everything we can, to take care of the natural world that takes care of us. Well, we have a choice. Some of my friends, astronauts, they want to go to Mars, and they want to terraform Mars. They want to make that red planet more like the blue one. But perversely, we are Marsiforming Earth. It's one of those things. We are. Whether it's through agriculture that has, in some ways, been the primary, fundamental blessing that makes our prosperity possible, but there's a downside, the cost to the natural systems. And in the ocean, the same thing. The fleets and trawlers that drag the ocean floor like bulldozers that take everything. We're Marsiforming the natural world. Fortunately, nature is resilient. Even with all of our mighty powers, we haven't succeeded in undoing the natural world yet. And good news further, there are a bunch of kids coming along who do get it, who do want a world at least as good as the world that we've known. And if they get it right, it's going to be better. If we get it right, we'll give them a chance to make it better. Last July, I was in Hong Kong. 1,000 school kids. They're 4th and 5th graders taking the pledge. We will protect sharks. We will never eat shark fin soup. And then, of course, they have to go tell their parents that too. But there's reasons for hope. Lots of reasons for hope. These kids, high school kids, and college kids going out to the Northwest Hawaiian Islands to drag back those derelict fishing nets, get them out of the ocean. We could do that here in our backyard as well. You can't see what's on that t-shirt, I'm afraid, because of the light, but it's just a lovely emerald blob representing Prochlorococcus. Prochlorococcus. They should be on t-shirts everywhere. We should all have little green spots on our forehead to remind us that 1 in every 5 breaths we take happens owing to the existence of this little blue-green bacterium that we didn't know about when I was a kid. Penny Chisholm, an oceanographer from MIT with her colleagues, using a new technique for studying phytoplankton, discovered this about 35 years ago. And as the studies continued, it turns out it's really abundant, really widespread, and 1 in every 5, 20% of the oxygen in the atmosphere comes from this one kind of blue-green bacterium alone. We better take care of those little guys. Take care of the ocean that does what it takes to maintain the integrity of a planet that works in our favor. So, here we are at this point in history. I think if we could do one thing, the thing I personally am dedicated to doing, whether it's on the land, freshwater, ocean, the fabric of life, it's to protect the natural world. We don't know how to make more of it. We know how to consume it, we know how to change it, we know how to put things on a different track. But it would seem to me that what you are doing with conservation biology is exactly the right thing. And it doesn't have to be your career, but it can be your ethic of taking care of the world that takes care of us. We have basically about another 10 years, maybe the most important in the next 10,000 years, to make a difference. This is the most important juncture in history. And why do I say that? Because of that envelope of tipping points. if we continue business as usual, how long will it take us to get rid of all the sharks? Got 90% of them. So, or the tunas, or the swordfish, the cod, the herring. They aren't all of them down to as little as 10%, but we're on a trend from here to here. Coral reefs, are we going to be the last ones on Earth to know what a healthy coral reef looks like? I hope not. And we have the power to turn things around. 50 years ago, it was too early. We didn't know enough. 50 years from now, it's likely to be too late. Now's the time. Thank you.
I was able to get the video running because I switched to the actual show.
If they want to see it, yeah. Do you have a minute? Okay. There's another great reason for hope, which I was going to give it up, but I've been convinced that it's only 2 minutes. So if you don't mind, we'll show this little piece. This comes from, if you can get it up there, Google. I remember before there was Google. The pre-Googleozoic. 2006. If you can just hold it on that first image. Oh, that's right, let it run. And I'll tell the story.
I'll turn them up here.
You hold the world in your hands. I mean, you can do this on your iPhone, you can do it on your desktop or your laptop, and now you can fly around the world and you can dive into the blue part. Going back to 2006, you couldn't. It's only 2009 that the ocean in Google Earth happened. And you can do this, and you can make your own little expeditions and lock them in and take people there on tours. This is a virtual tour just to go to some of the places that I particularly am fond of and want to see protected because they have a magnified impact on the way the world works. Like our national parks have a magnified impact on the systems as a whole. The reservoirs, we need similar areas in the ocean as priority places. Well, we need to take care of all of it and use it with care. But Patagonian shelf, we need to get the squid fleets out of the Patagonian shelf. The squid, as in the krill in Antarctica, are cornerstone species that are really vital. And wherever in the world you choose to fly, now you can do this. This is in Australia, the Great Barrier Reef. It was one of the very earliest marine protected areas. Now the Coral Sea that borders the Great Barrier Reef is targeted for protection starting this year. There is a trend, finally. Only about 1% of the ocean has some form of protection. The land doesn't have enough either. It's only about 14%. If you think of the natural world, think of the ocean in particular. Here in the Mariana Trench, where James Cameron made the second descent in history. This depicts the first descent in 1960, when 2 men went to the deepest place, and they came back, which is the critical part. So you can click that off now. But imagine before Google, you just couldn't, and it isn't just, it's this whole age that we now share. Google is just one dimension of it, to be able to ask questions, to gather information, to fly around the world. When I first met John Hanke, who came up with this concept, he had a company called Keyhole. It was considered super top secret. Don't let the public know this. It was during the Cold War era when a lot of investment was made in technologies that stayed behind closed doors. But the company that John Hanke, who's now with Google, started, they called it Keyhole, were able to take some parts of that technology that enable you to hold the world in your hands and fly around. And when I first learned that this company existed, for $600, you could download Keyhole and fly around the world and see, the world in context. And they began to add things to it, and then Google snapped it up. So it became Google Earth. And then I had to pay another $600 to get Google Earth. Now it's free, but at that point when they're just starting. And I was at a conference in Spain. There were about as many people at this conference in the auditorium as there are here. And John Hankey was sitting right up front. I hadn't met him before, but I was so enthusiastic about Keyhole and Google Earth that I had 15 minutes to say why the ocean matters, but I took my first few minutes and said, thank you, John Hankey, thank you for Google Earth. I can fly around, I can see my backyard, I can see my neighbor's backyard, I can fly the Grand Canyon, and I can find Starbucks, which is really important. And it just popped out. It was unscripted, all of it was. I just said, and I hope, John, someday you'll finish it because, you've neglected the ocean. It's just a big blob of glue. And I went on to say, and you should call it Google Dirt. And instead of being insulted, he said it was like getting stabbed in the heart. And afterwards, he pulled me aside and we had a chance to talk. He said, you must come down to the Googleplex. You must talk to the Googlers and tell us what we need to do, because I realized something was missing. And I just couldn't resist, and I said, yeah, like most of the world. It's true. And the Googlers took their 20% time, some of them, and it took them 3 years to solve the tricky problems of being able to dive through the surface and know that you were under the surface, to be able to go deep. They could go high, they could go to the moon, up, but they couldn't go down in the method that they had for showing people Earth. They solved all that, and so now, the big problem is we've only mapped about 5% of the ocean in any great detail. So it's kind of vague in a lot of places. So there's a lot to do. Anybody want to make a difference? Go map the ocean, or go work at Google and get what knowledge we've got and put in there. But, you can link in, dive into places and see what it's like. And I think that it's not perfect. It's better to go dive in yourself, go get wet, but maybe it'll encourage you to go do just that. So again, thank you for inviting me here. Thank you for listening. Thank you for all that you're doing to take care of this little blue speck in the universe. It's what we need to do, all of us. Thank you.